This lecture talks about controlling for selectivity biases and quasi-experiments. The big thing about quasi-experiments is that they are non-randomized and they're selected. So groups are selected. The controlled group and the treatment group are both selected. And every time you select groups in any design, you stand a chance of committing selectivity biases. I would assume in this lecture that you have a strong understanding of the threats to internal validity and also like other things that happens in a quasi-experiment, specifically the introductory part of it. So I'm just going to go into some of the things researchers do to control for selectivity biases and more or less make their quasi-experimental designs almost as good as a RCT or even better sometimes. So the first thing I want to talk about today is multiple pretests. In multiple pretests, what happens is, again, this is your treatment group, this is your control group. You do multiple pretests before your intervention. So this is the intervention and then your post-test. In the same thing in the controlled group. So multiple pretests, treatment as usual, and then your post-test. Why am I doing multiple pretests? You understand that in a minute. Take a look at this example. Let's say you are implementing an intervention for depression, and these numbers here are a score on a scale, some depression scale. And if you notice what's happening here is this individual, which is in the treatment group, has a score of 50, and then by the end of the intervention, he has a score of 35. And if you look at the controlled group, you see 51, 51, and it's still at 51. So you're like, oh yeah, my intervention worked great. This is exciting. This is good stuff. Unfortunately, look, if you pay close attention to the multiple pretests, you would see that there was already an ongoing pattern of decline before the intervention was applied. So you going from 50 to 45 to 40, and then the intervention is applied, it drops to 35. I can preempt myself here and say that if this intervention was not applied, chances are that the score would have still dropped from 40 to 35 just by itself. For some reason, this is a clear case of selectivity bias. Selecting an individual or a treatment group that is already on a decline, regardless of the intervention, is the clear case of selectivity bias. What we want to see is something like this, where the multiple pretests show no pattern of decline or no pattern at all whatsoever, just all around the place. But the moment the intervention is applied, it drops drastically. That is what we want to see. And then the comparison group stays the same. And that's multiple pretests for you. The next thing I talk about is switching replication. I like switching replication a lot because it's easy to define and it's easy to talk about. It's just we switch and we replicate. As easy as that. The intervention that is being applied here after the pretest is switched and replicated to the controlled group. Now, we have, of course, the pretest, intervention, post-test. In the control group, we have the treatment, pretest, treatment as usual, post-test. Now, after the post-test, we apply the same intervention we applied to the treatment group and do another post-test just to see. Now, this is what we want to see. At the end of an intervention, we get a score. After switching replication, we want to get the exact score we got from the treatment group in the control group. Now, it tells us that this score obtained is solely due to the intervention applied and nothing else, as in regarding selectivity and what have you. What we do not want to see is intervention applied, we get the score of 60, and then switch, replicate, intervention applied, and we still get to the same score. It means that there was some selectivity issue here. So it's not lacking. It's not without selectivity bias. Non-equivalent dependent variable is, for me, one of the most problematic approaches to controlling for selectivity biases, because even though it's being used couple times, it's problematic because I'll just give you an example that nails it. You're doing an intervention to prevent smoking or to like control for smoking cessation. Smoking cessation program in teenagers or adolescents, and then you do all these educational models where you show them things that kind of like tells them the deleterious effects of smoking. But at the end of your intervention, you decide to test that knowledge. So their knowledge of smoking and what to do about the whole smoking situation. But in addition to that, you decide to also test alcoholism, knowledge for alcoholism, even though you did not apply an alcoholism intervention program. Now, what you would notice, most of the time is that they would do well on the smoking part, but they won't do well on the alcoholism because you didn't teach them alcoholism. That's what the goal of the non-equivalent dependent variable. In this case, alcoholism is a non-equivalent dependent variable. Again, remember that we talked about dependent variables as the outcome, what we want to see. So independent variables are the cause, and then dependent variable are the effects, the outcome we want to see. Now, I say it's problematic because sometimes after you've done all of these and done all that, um, alcoholism might still show some improvement because, like, if when people are changing, they change on a bevy of attributes. They change around a couple group habits, basically. When someone is trying to quit smoking, he starts reading things about like maybe dependencies and all that, and then they might even decide to quit drinking too, and it has nothing to do with your intervention. So non-equivalent dependent variables are not very effective as far as I'm concerned. It might be a personal bias to it, but yeah, that's basically what it is. Yeah. So to recap, all of these guys, multiple testing, multiple pretesting, switching replication, and non-equivalent dependent variables are used to answer the question: did your intervention produce the results? And only your intervention. So we want to know if your intervention was the only thing that produced the result and nothing else, of course, as regards to selectivity biases. So if this video was helpful to you, I would invite you to subscribe to my channel, like my page, and turn on notifications so you can catch all my recordings as they come up. Thank you.